Hello everyone, welcome to our channel once again. I hope you are all good. In today's lecture, we are going to start a new chapter for class 10th, that is trigonometry. This trigonometry, it is a branch in the mathematics that studies the relationships between the length of a triangle and the side of the triangles. So I'm writing out the definition here. It actually deals with or studies the relationships between the side lengths and angle of a triangle. So, it is a definition of the trigonometry, and it is the branch in the mathematics in which we are going to establish the relationship between the side length and the angle of triangle. Let us try to understand. For example, if I am having the right angle triangle, mostly in trigonometry we use a right angle triangle, right? As you can see here, I am having three sides. Here's my first side, let it be the first side, let it be the second side, and let it be the third side. So totally in the triangle, I will be having three sides. And as you can see here, I am going to have three angles. It is the first angle, it is the second angle, it is the third angle. Let it be the point A, let the point B C. So as you can see here, I am having here three sides and I am having here three angles. In a right angle triangle, one angle will be known, that is 90 degree. As you can see here, this angle is nothing but 90 degree, and the other two angles are unknown. So mostly in trigonometry, while dealing, if any other triangles are given, we will turn those triangles into right angle triangles, and then we use the trigonometry into the triangle. For example, if the triangle is given like this, then what we will do is that we will just draw a line in the center. As you can see here, it's a A, it's a B, it's a C. From the point A, I am drawing a line, and this line is joining the line BC. I'm just marking this point as D. As you can see here, this line is making an angle 90 degree with the line BC, and here too, this triangle, if you can see, triangle ADB, in this triangle too, this line is making 90 degree with the line B and D. So as you can see here, we use the trigonometry in our right angled triangles, right? If right angle triangle is not given, then in that triangles we ourselves make a right angle by drawing a line, and then we will apply the trigonometry. So let us understand first sides. Here we are having three sides. It is my first side, it is my second side, and it is my third side. So as I am having three sides, I am going to give the names different for these three sides. So how to give the names? So remember, the side which is facing the 90 degree, side facing 90 degree, side facing 90 degree is known as hypotenuse. The side which is facing the 90 degree is known as hypotenuse. So this side is now known as hypotenuse. Alright. Now I am having here two angles. Now if I am considering, I am going to find out this angle, for example angle C. So I should have to see these two sides with respect to angle C. Why I am saying why I should have to see these two sides with respect to angle C, you will be coming to know within few minutes. So let us first understand, if I am seeing with respect to angle C, with respect to angle C or first side. So if I am going to find out the angle C, the side which is facing the angle C will be known as the opposite side. Side facing angle C is known as opposite side. This opposite side is also known as perpendicular side. Yeah. Next, I'm having one more thing, the last side. So I just found out the hypotenuse side. How to find out the hypotenuse side? Exactly the side which is facing the 90 degree, that side will be known as hypotenuse. So whatever the angle I'm going to find out, the side which is facing towards that angle will be known as opposite side, and the last side will be known as, this second side is known as adjacent side, right? Last one is second side, is the first side, is the third side, and it is the second side will be known as adjacent side. This adjacent side is also known as base. So I am just repeating once again, the side exactly facing the angle C is known as perpendicular, and the last side will be known as the base or the adjacent side. It is how you should have to find the sides of the triangle, right? So it is the first side. You should have to write, you should have to first denote where the hypotenuse side, and then you should have to find out where is the opposite side, and then next you should have to find out which is one is the adjacent side. If you found two sides, right, you have to find the hypotenuse side, then you should have to find the opposite side. The last one will be automatically the adjacent side. So while finding, you should have to first find the hypotenuse side, right? So the side which is facing the 90 degree will be known as the hypotenuse side, right? And the side which is facing the angle C is known as the opposite side, and the last one will be automatically known as the adjacent side. In some books, this opposite side will be given as perpendicular side, and last one adjacent side will be given as base side. So it is with respect to angle C. Now I am going to see with respect to angle A, right? Because these two angles are unknown, right? Now I am going to see with respect to angle. I'm writing here with respect to angle A. So with respect to angle A, what will be the changes in the sides? So what is the angle here? It is the angle A. Now I am going to find the angle A. If I am going to find the angle A, so for this angle, the opposite side will be the side which is facing this angle, right? It is the second side which is facing the angle A. Therefore this side will be known as, second side will be known as opposite side, and the first side will be known as adjacent side. Here it is the first one which is acting as the opposite side, and second one acting as adjacent side. But if I am considering the angle A, you can see that the second one acting as opposite side and the first one is acting as adjacent side. So here you can see that there is a changes once if I am just changing the way of the angle I am seeing. If I am seeing for the angle C, the opposite and adjacent side is different. If I am seeing for the angle A, then the opposite and adjacent sides are different, because these two angles are unknown. So opposite and adjacent side selection depends upon what angle you are referring, right? So now, as you can see, now it's clear. So based upon the angle what you are referring, you should have to choose the opposite side, you should have to choose the adjacent side, and hypotenuse will be constant always. Exactly, that means the side which is facing the angle 90 degree will be known as hypotenuse side. So here it is clear how to find the opposite side, how to find the adjacent side, and how to find the hypotenuse side. And you also came to know about the angles. Alright, yeah, we will speak about this later. Now we will do something, that means we will do some triangles in which we will be able to find the opposite side, adjacent side, and hypotenuse side. Yeah, as you can see here, I am going to draw a triangle. Yeah, it is a triangle, you can see. Yeah, I'm saying to find the angle theta. Right, I'm saying it is a theta given. It is a theta given to us. It is A, it is B, it is C. Now I'm saying to say the sides here. Which one is acting as opposite side, which one is acting as adjacent side, and which one is acting as hypotenuse side. Let us see. First we should have to mark the hypotenuse side. It is the 90 degree, right? It is the right angle triangle, therefore this two lines making an angle 90 degree. So this side will be known as hypotenuse side, right? Because this side is exactly facing the angle 90 degree, therefore this side will be known as hypotenuse side. Now we should have to opt for the opposite side and adjacent side based on the theta given. As you can see here they are asking for this angle. Angle representation is theta. What is the angle representation? Angle representation, yeah, angle representation is theta. How to represent an angle? Theta. Theta is the angle made between the line AB and AC. Theta is the angle made between the lines AB and AC, and the angle representation is theta, right? So with the reference of this theta, I can say the side which is exactly facing the theta will be known as opposite side, and the last side will be known as adjacent side. If the same triangle I am giving here by changing the theta, it is the A, it is the B, and it is the C. Now I am saying that AC and BC are the lines which is making an angle theta, and now you should have to choose the sides names, right? So now say me the side names. It is the 90 degree, therefore this side is going to be known as hypotenuse because this side is facing 90 degree. Now as this is the angle theta given to us, or we are going to find, so exactly the line which is facing the angle theta, will be known as opposite side, and the last side will be known as adjacent side. Now it would have been clear to you how to find the adjacent side, how to find the opposite side, and how to find the hypotenuse side. So you should have to understand, first thing you should have to mark is that hypotenuse side. Second thing you should have to mark the opposite side, and the third is adjacent side. Now I'm going to give you one more triangle. Yeah, it is a triangle given. Yeah, it is a triangle given, as you can see here, right? Yeah, if I am saying this triangle is making 90 degree here, it is the point A, it is the point B, it is the point C, and I am asking for this theta, right? Now I should have to mark the sides, right? Which side? So as you can see here, as it is making an angle 90 degree, as you can see here, Now the line which is facing the angle 90 degree will be known as hypotenuse side. The side which is facing the theta, you can see this side is facing this angle theta. Therefore this side will be known as opposite side, and the last side will be known as adjacent side. So whatever it may be, however complex the triangles may be, if once we know where is the theta and where is 90 degree angle, right, so we can easily conclude where will be our sides, where will be our hypotenuse, where will be our opposite, and where will be our adjacent. So it depends upon angle what they are asking. So now it would have been clear how to mark the opposite side, how to mark the adjacent side, and how to mark the hypotenuse side. Now we will move to the ratios, trigonometric ratios. Right. As I already said, trigonometry, it is study of the relationship between the side length. It is a side length AB, BC, and CA are the side lengths, and the angle of the triangle, angle A, angle B, and angle C. Right. Out of these three angles, one angle will be 90 degree. Yeah, it's too clear. So now I am going to establish the relationship between the side length and the angle of triangle. How? I am going to make the ratios first. Yeah, as you can see here, I am going to make the ratios. So what will be the possibilities for making the ratios? As you can see here, I am just going to draw. That will be possibility for opposite upon hypotenuse side. That might be the ratio. I'm just trying to just write the possibilities. What are the ratios I can make? So here it is the first ratio I can make, opposite upon hypotenuse. Second ratio I can make is that adjacent upon hypotenuse. It is my second probability. And my third possibility is that I can divide these two. I can make the ratio of these two sides. That is opposite upon adjacent side. So as you can see here we are having three possibilities. One is the one I can make the ratio with this side upon this side. Then I can make the ratio upon this side upon this side. And then I can make the ratio of these two sides. I made it. Is there any more possibilities there? Yeah, I can even write. Yeah, there are some more three possibilities. So what are those three possibilities is, you can see here, it is opposite side upon hypotenuse. I can write it as hypotenuse upon opposite side. Right? It is a reciprocal of this. Right? Yeah, you might be having a doubt. These both are same. Opposite upon hypotenuse and hypotenuse upon opposite is same. No. What I am asking you is that, is 1 by 2 and 2 is same? Is 1 by 2 and 2 is same? Because 1 by 2, the reciprocal of 2 is 1 by 2. Is 1 by 2 and 2 is same? No. The 1 by 2 is nothing but it is 0.5. It is not equal to 2. Right? Is 1 by 2 and 2 is equal? No. Of course no. Right? Like this say, I am just taking out the reciprocal. It might be the value for this may be 2. The value for this might be 1 by 2. Right? Okay. So I am just taking this possibility. I am just turning out this. I am just taking the reciprocal of this. So I can even take the reciprocal of this possibility, that is hypotenuse upon adjacent. And I can take the possibility, I can take the reciprocal of this possibility too, that is adjacent upon hypotenuse. Yeah. So totally I am getting 6 possibilities. Totally I am getting 6 possibilities. That is why in trigonometry they are studying only 6 trigonometric ratios. Right? So what are those ratios? They given this ratio, the name given to us is sin theta. For this ratio they given as cos theta. They given as tan theta. Right? This ratio is known as cosecant theta. This ratio is known as secant theta. This ratio is known as cot theta. Right? So these are the 6 possibilities of the ratios I can make with the length of the sides. Right? So for these 6 ratios, I have to establish the relationship with the angles. So it is the relationship between the angle and the length of the sides. That is what we are studying in trigonometry. So here I am having 6 relations of the angles and the sides of the triangles, right? So here the sine theta formula is opposite side by adjacent side, cos theta formula is adjacent side by hypotenuse side, tan theta formula is opposite by adjacent side. So the reciprocal of opposite by hypotenuse is a hypotenuse by opposite. It is known as cosecant theta. Hypotenuse upon adjacent is known as secant theta. Adjacent upon hypotenuse is equal to cot theta. Right? So these are the 6 trigonometric ratios we are seeing. Why can't we make it 7? Why can't we make it 5? Because we are having only 6 possibilities. That's why we are just only considering 6 trigonometric ratios. And what are those angles? Sine theta, cosine theta, tangent theta, and then cosecant theta, secant theta, and cot theta. These are the 6 trigonometric ratios. Now I am going to introduce one more thing. As you can see, I can write this as 1 by opposite side by hypotenuse. Yeah, of course I can write this as 1 by opposite side by hypotenuse. Right? So opposite side by hypotenuse is known as sine theta. Therefore cosecant theta is also equal to 1 by sine theta. Right? So I am getting one more formula for the cosecant theta, that is equal to 1 by sine theta. I am going to write here one more thing, that is 1 by hypotenuse upon opposite side. Can I write this? Yeah, of course. In the denominator I am having the fraction. So whenever in the denominator there is a fraction, we will do the reciprocal of this. So if I am doing the reciprocal of this, I will get opposite upon hypotenuse. That means I not changed the equation yet. I not changed the formula yet. It is still correct. Yeah. So 1 by hypotenuse upon opposite, and hypotenuse upon opposite is known as cosecant theta. Therefore I can write it as 1 by cosecant theta. Like the same, it is cos theta is equal to adjacent upon hypotenuse. It is a reciprocal of that. Therefore it will be equal to 1 by secant theta. You just try to do like this. Then next, it is known as 1 by cot theta. This is the reciprocal of 1 by cos theta. It is the reciprocal of tan theta. That means 1 by tan theta. So as you can see here, I made some more new formulas. So totally I was having nearly 6 formulas. Now I am having 12 formulas. I introduced 6 more new formulas. But actually it's not new. It's not new. It's already we know. Because it is a reciprocal. We are just that means we are doing a reciprocal here. These are 4th possibility for making the ratio. I am just doing the reciprocal for this ratio. I am getting this ratio. I am doing the reciprocal of this ratio. I am getting this ratio. And this ratio is equal to this tan theta, right? And this ratio is this ratio is equal to sin theta. So if I'm doing the reverse thing, that means I'm doing the reciprocal for this ratio. Therefore I can even reciprocal this sin theta upon 1. Sin theta upon 1 is nothing but 1 by sin theta. I done the reciprocal thing. So we are getting from this formula. So these are the 12 formulas you should have to by heart. Right? So if I am asking you what is sin theta, you should have to say sin theta is equal to opposite by adjacent side. If I am saying you to say in the that means you can say in the form of trigonometric functions. In the form of trigonometric functions, these 6 are trigonometric functions: sin theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta are the trigonometric functions. If I am saying you to say in the form of sides, then you will say sin theta is equal to opposite side upon hypotenuse. If I am asking you to say in the form of trigonometric ratios, then you should have to say that sine theta is equal to 1 by cosecant theta, or cosecant theta is equal to 1 by sine theta. If I'm asking you to say the formula for the tan theta in the form of sides, so you will say that tan theta is equal to opposite side by adjacent side. If I'm asking you to say in the form of trigonometric ratios, then you should have to say tan theta is equal to 1 by cot theta. Right? Fine. The next thing, so for tan theta, I am getting one more formula. How I am going to write one more formula for the tan theta? You can just watch this. Like, it is opposite side by hypotenuse and it is adjacent side by hypotenuse. I am just rubbing out this triangle. I am going to write this opposite side by hypotenuse upon adjacent side by hypotenuse. So here for the tan theta, I got the tan theta will be equal to the ratio of the sides opposite upon adjacent. As it is going to be equal for the ratio of these sides, I'm just trying out whether I'm getting this ratio upon dividing these two ratios or not. I'm going to divide these two ratios and I'm checking out whether I'm getting this ratio or not. So I'm dividing these two ratios, as you can see here, opposite upon hypotenuse and it is adjacent upon hypotenuse. As you know already, if in denominator it is given in the fraction, then it will undergo reciprocal. So it will also undergo reciprocal, right? And then once it undergoes reciprocal, it will become as opposite side upon hypotenuse. So while going to the numerator, it will go reciprocal. So here it is hypotenuse upon adjacent, right? So as you can see here, I done the reciprocal thing here. As it is in the denominator, it is in the fraction. So I have to do the reciprocal while going to the numerator. As it is going to the numerator, I done the reciprocal thing, and this hypotenuse and hypotenuse is getting cancelled out. Now it becomes as opposite side upon adjacent side. Therefore, upon dividing these two ratios, I am getting this ratio. Therefore, I can say that sine theta upon cos theta will also be equal to sine theta upon cos theta is also be equal to tan theta. If sine theta upon cos theta is equal to tan theta and cos theta is nothing but equal to 1 by tan theta, therefore I can even write this as cot theta is equal to cos theta upon sine theta, right? Yeah, I'm going to write here tan theta. Instead of tan theta, I will write sine theta upon cos theta. So while going in the numerator, the reciprocal thing will happen. So here it is sine theta upon cos theta. Cos theta will go to the numerator and sine theta will be in the denominator. So I'm getting one more formula for cos theta, that is cos theta upon sine theta. So here we studied today nearly 14 formulas. And based on the 14 formulas, I am going to do problems tomorrow. And it's very essential that you should have to know each and every formula. So you should have to study by today each and every formula. Right? So in the tomorrow's lecture, I will be giving you the angles. We will be studying like loving angles, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. How to get the values for those angles, we will study in the next lecture. Along with that, we will also even study trigonometric identities, and I will be giving you the proof for those trigonometric identities in the next lecture. If you like this video, then comment it, share it with your friends, like it and subscribe it. Even if you have any more doubts, you can ask in the comment section, and just please share it with your friends and support our channel.